Welcome to Basics Part 2. So Part 1, we talked about distance, time, we built velocity with it, we developed acceleration. Velocity is just distance by time, acceleration is the change in velocity over time, or the second derivative of distance, as you would call it if you are a calculus student, right? Now we're going to introduce another sort of intrinsic variable when it comes to studying motion. There's an object, it moves, we're studying it, but that object has a certain mass, right? We'll just call it mass, and how much of the object is there. Remember, not weight, mass. We'll talk about weight further down, or maybe when we get to the intermediate part of this, right? We'll introduce mass. I'll write that here. It's almost like saying how much of the object is there, right? That might be a nice way of thinking about it. Now mass, I'm going to use uppercase M in this case because I'm using the lowercase m for meters, and I don't want to confuse you here. So just for the purposes of this, typically that wouldn't be the case. You would find a lot of textbooks using the lowercase m for it, right? So a cursive lowercase would work, but in this case, just for simplicity, I'll use uppercase M for mass, and its unit typically is kilograms. kg. Now remember, I'm using the metric system everywhere, so I'm not using pounds or feet or those kind of measures. It's meters and kilograms, right? So mass, how much of an object is there? And let's see what we build with it. So an object moves, it has velocity, and its motion can get quantified with these two aspects. And use an example of something small like a bullet. Travels really, really fast, but has a lot of impact, damaging impact. Or a fast bowler who can cause damage just because he bowls at 140 kilometers an hour or more than that. The ball itself, probably not very heavy, but the velocity that it has created an impact. Therefore, its motion typically gets stated well with these two variables coming together, and they come together in what is called as momentum, right? And I'll introduce that. Momentum we'll use a lowercase p to denote momentum, and quite simply it's the product of mass and velocity. And it's really what that motion is all about. Take a young child trying to swing his arm at you or push you, you don't really get much out of it. But if it's a really, really heavy person, if they nudge you, you'd probably feel it. Mass created an impact. Or take someone rather light and lean like Bruce Lee and his 1-inch punch that can actually send an opponent far away. What happened there? He's not a very massive guy. He wasn't a very massive guy. But that pace, he was able to create so much of impact because velocity was very, very high. Same with a bullet. A fast-moving bicycle causes less damage than a fast-moving car. Mass, right? So things like that. So momentum is really what that motion is all about. And really, that will help us understand most of everything else that we're going to study in mechanics, right? But we'll keep this there and introduce the next important part. And this is the intrinsic property, I would say, of all objects. Studied by astronomers, I think they go back to Aristotle, there's Chinese astronomers, there's various, they saw objects that were unrest and they just stayed there. And when they looked into space, they just found objects moving and things just moved. And they came up with this concept that objects typically just want to stay in the state in which they are, right? And we'll introduce this and I'll call it here. I'll write this entire thing in uppercase because this is important to understand, and it's the foundation of pretty much everything else that we would learn in mechanics and physics. It's inertia. And inertia is really the inherent property of an object to resist any kind of change. So an object wants to continue and be in the same state, and I'm kind of building on this principle of inertia to say, if you were at rest, you'd stay at rest. If you were chilling, you just want to chill. To get you to do some work probably is not going to be easy. If you'd have to do some chores, you wouldn't want to do it. If you were enjoying playing video games and were just at it to get you to study mechanics, that'd be tough. You would resist that change. And then, we'd have to figure out a way to motivate you. That's inertia. It's the inherent resistance to change. Now, we'll build on that, right? And we'll build on it and say the law of inertia, and I'll just write that there. The law of inertia. And I'll kind of phrase it in a very simple way. An object's state of motion does not change. Okay, and I'm using a generic term, state of motion. You'll find textbooks that say an object at rest continues to stay at rest, or an object in a state of uniform motion continues in that state. But to me, rest means velocity is zero because s is zero, and uniform motion means acceleration is zero because velocity is constant. So the derivative of velocity is zero. So I'm just using the generic term, but textbooks use them, have different definitions. And it's packaged under Newton's first law of motion. It's effectively a derivative of the law of inertia. So an object state of motion does not change, and here's the key, unless and I will use another color, a force acts on it. A very, very simplified way of stating Newton's first law. Again, remember, textbooks classically will say an object at rest continues to stay at rest, or an object in motion continues to stay in motion until a force acts on it, right? And that is where we will get to this concept of force in the next part of our basics, because that is important, forms that building block over which everything else gets set up, right? So in this part, remember momentum and ability to figure out a value to that motion, right? What is that motion doing? And that's in momentum. Object at rest, obviously no momentum, velocity is zero. A light object, lower momentum. Momentum can increase if velocity was higher. A heavy object, moving very slowly, still low momentum, right? Remember that, and remember Newton's first law, and that introduces us to force, which we'll discuss in part 3 of basics.